My name is Dr. Philip Shepherd, and in this presentation I'm going to talk to you a little bit about myself and also what it's like to study A-level physics here at Scarborough UTC. I've been an A-level physics teacher for 25 years. Not only have I taught A-level physics, I've trained other people how to teach A-level physics, I've led training courses, I've been a professional examiner, and I've been a head of department. I'm pretty confident that if you join us here at the college, that I have the resources, know-how and experience to ensure that you make a success of this course. Okay, let's talk about the A-level physics course itself. So physics is a very broad area of study. It includes things like electricity, light and waves, and mechanics, as well as dealing with the very large, such as galaxies, and the very small, such as subatomic particles. What all of these areas have in common, however, is an attempt to find a set of rules that explain what we see and then use those rules to solve problems. Physics is the most fundamental of all sciences, as it attempts to find a set of rules to explain everything that we see. Thus, biology and chemistry and geology and all other sciences are built on top of physics. Because of this, physics is an enormously important subject for further study and employment. A-level physics is a required A-level for many engineering, science and applied science courses at university, as well as for many jobs and apprenticeships. On top of this, at the end of 2 years of studying A-level physics, you're pretty good at solving problems, because that's essentially what we do. We find out what the rules are, and then we use those rules to attempt to study lots of different problems in lots of different situations. You may be concerned about what's going to happen to your studies in September because of the pandemic, and you're right to be concerned. Now, here at Scarborough UTC, we've taken an approach whereby students have live lessons and live contact with their teachers. So this is a message I sent out on Google Classroom telling students that this week there was going to be a live 1 hour lesson where we were going over a Year 13 topic. I have spoken to my students via video link every week since lockdown began. It's not just been a matter of putting work online and expecting them to complete it. It's been a matter of live lessons, one-to-one feedback and one-to-one tutorials. Every student has had live contact with me during this period. Every week a student has had an assignment which they have completed and handed in online. I've marked it and returned it. Here's an example of the marking. Every point is marked. There's a commentary on that marking for the student to refer to and to respond to. And on top of that, I would have had a one-to-one session with them going through what I considered were the strengths and weaknesses of that work. Because of this, no student in Year 12 physics is behind because of the pandemic. And I am confident no matter what happens in September, we can ensure that you make progress through the course. Okay, on to some more conventional stuff. What is it we teach? So it's AQA Physics Specification 7408. You can look that up online. Year 12 is very conventional, deals with a bunch of GCSE topics which you've seen before, but they're done in a lot more depth, they're done more mathematically, and with a great deal more detail. And in Year 13 are some topics that you either won't have seen before or only done very, very briefly, such as electrical fields, nuclear physics, how nuclear power plants work, and there's also an option. And what normally happens is I sit down in my class sometime during Year 13 and decide which of the options they want me to teach. Normally I've tended to find here at the college that the students want to study the engineering option. How do we go about teaching it? Well, this is my existing plan for the first term of Year 12. So we have an electricity topic in Year 12, and that is broken down into 5 modules, 2 of which are taught during the first term. Each module or unit consists of a recap of previous work, then the new work, and the development of new skills. It has a practical and an end of unit test. So what we do is we build up your knowledge of each topic gradually during the course of the year, giving lots of time for reflection and learning and revision. At the end of year 13, you're examined by 3 written exams. We do not do AS exams here at the college. Okay, let's talk about our facilities and resources. One of the reasons why I decided to come and work here at the college is it has excellent resources and facilities. As you may know, education has gone through a funding crisis in the past few years, and it's unusual to come across a school and college where there is this much kit. This is our laboratory. I also have a physics teaching classroom. The laboratory is full of apparatus, and indeed much of the apparatus is only 2 or 3 years old, or indeed brand new. It means that I can plan to do practical work in a way that I want to. I don't ever feel that I need to shortchange students by saying, we don't have that piece of apparatus, we don't have that kit. We have lots of opportunity to do practical work and lots of resources to be creative with it. And it's really, really good. There will not be many schools or colleges as well resourced as this in the area. And that means that basically we do way more practical than is required by the course, because we can. Top of that, every student gets a textbook, a revision guide and a workbook, as well as access to all of my online resources. Okay, practical assessment. Now this is the same for all A-level sciences. So everybody has to take something called the Common Practical Assessment Criteria, which is a pass or fail qualification. So what happens is during a practical session is I assess your practical skills. For instance, I may decide in one practical to see if you are working safely. And then at the end of the course, I decide if you are competent at practical work, and if you are, then you pass CPAC. The outcome of your practical assessment has no impact on your final written grades, which are entirely based on your written papers. You also need to do 12 specified practicals, and we need to keep records of that, but that's easy for us because not only do we do those, but we do a whole bunch more as well. And it's very unusual for students to fail CPAC, very unusual indeed. Failure at CPAC normally involves a student who has failed to attend school or college. Minor note here about maths and physics A-level. A-level physics is an intensely mathematical subject. Every lesson will involve calculations and algebraic manipulation, graph drawing. We would expect most students who are doing A-level physics to be studying maths. Now, it's not a requirement to study A-level physics that you are studying A-level maths, but if you're not studying A-level maths, ask yourself the following question. Are you not studying A-level maths because you have been told that you will not succeed at it? Because if you have been told that, and if you don't feel confident that you can be successful at A-level maths, you are extremely unlikely to succeed at A-level physics. Together, the combination of A-level maths and A-level physics is extremely powerful. A-level physics by itself is less useful and also makes the subject more difficult for the student. So if you do wish to study A-level physics without maths, it's important that you talk to us about that choice, and we can advise you whether that's appropriate for you. Finally, you can always contact me at the University College using the link shown there. I'm happy to answer any additional questions or queries you may have about the course. I hope you found this useful, and good luck in your future studies. Thank you for your time.